All right, good afternoon, geometry. I was going through your chapter 9 tests, and I can't help but notice that some of us are still, we're struggling to put all of these pieces together to solve a triangle. So I'm going to have a look at problem number 1, and I'm going to choose the letter N. So letter N is going to be the number I'm going to use to plug in to find the value of angle ACB. So here we go. So you might recognize this. It's probably test question number 1. This is what we start with. We are given three things. We are given that the length of CD is equal to 8. We're given the length of AD is equal to 5. And we're given that CD is perpendicular to AB. Now what I did is I put the two 90-degree indicators up there to show that I have two right triangles, basically. All right? So, and what I need to find is I need to find the measure of angle ACB. In other words, this ACB, this big angle here, I need to find that. So N is a 14, so 48 plus 2 times 14, and that would be 76 degrees. So if your last name started letter N, you would have started with the measure of angle ACB is equal to 76 degrees. All right. So I need the measure of angle ACD. To find the measure of angle ACD, I have a couple different options I can use. I'm going to use one of my trig ratios. And I have an opposite and I have an adjacent. I have the opposite side and I have the adjacent side of angle ACD. So to find the measure of that angle, I'm going to use my inverse tan function. I'm going to say that tan neg 1 of the opposite, which is 5 over 8. And I'll enter that into my calculator. Turning on and clearing. So if I go second tan 5 divided by 8, enter, I find the measure of that angle is 32 degrees. I know it's 32.005, but we're going to call it 32 degrees. Okay? So the measure of this angle here is 32 degrees. So put that up here, 32. Well, if this whole angle is 76 degrees, well, 76 minus 32, that makes this 44 degrees. So the measure of angle DCB is 44 degrees. Now, while I'm at it, I can find the measure of this angle, can't I? I know that the interior angles of a triangle sum up to 180 degrees. There's 90 of it. There's 44 of it. That leaves 46 degrees. 90 minus 44, 46. Okay? I can do this one too, can't we? You see, 90 minus 32. Can I do that? Okay. All right. So I think I have the measure of all my angles. So the measure of angle BCD, that's 44 degrees. The measure of angle CBD, that's 46 degrees. Now I need some lengths. I need the length of AC. The length of AC. That says that I need the length of that hypotenuse of that right triangle. Now I could use some trig ratios to find that. I could go, cosine of 32 is equal to 8 over the hypotenuse. I could do sine of 58 is equal to 8 over the hypotenuse, or I can use the Pythagorean theorem. I choose the Pythagorean theorem. So the length of AC is going to be 5 squared plus 8 squared, and then I'm going to take the square root of that. So AC is going to be 5 squared plus 8 squared. Then I'm going to take the square root of that. Well, 25 plus 64 is equal to the square root of 89. What a thing of beauty. So the length of this over here is the square root of 89. Okay? Got it. All right, I need the length of BD. I need BD right there, BD. Okay? I'm going to use one of my trig functions to find that. It looks to me like I have the opposite side, and I need the adjacent side. Well, it looks like tan again. Only this time, I'm going to say that tan 46 degrees is equal to the opposite over the adjacent, over this thing that I don't know. So it's going to equal 8 over the length of BD. Or BD, multiplying both sides by BD, and then dividing by tan 46 is going to equal 8 divided by tangent 46. Okay? So let's see what that looks like on the calculator. So I'm going to go clear. I'm going to go 8 divided by tan 46. Close it. 7.725. 7.725, and I think the next one was a 5 also. So we'll just go ahead and take that all the way out. Yeah, after that it drops off to nothing. 7.7255. Okay, 7.7255. Okay, all I need now is the area of the triangle. I need the area of the triangle. So this is 7.7255. Okay, now I have a couple different options to find the area of this triangle. However, I think that if I knew the length of CB, I could use one of my areas for sine. If I could find the length of the base times the height divided by 2, and I could add the two triangles together, but I don't know AD. Yeah, I do. It's 5, don't I? So we have some options. What would you like to do? You know what? I think I'm going to do the base times the height and then divide it by 2, and I'm going to add the two triangles together. So this triangle, ADC, area that 5 times 8 divided by 2, that's going to give me a 20. So the area of this triangle is going to be 20 plus the base times the height of this one divided by 2 plus 8 times 7.7255 divided by 2. So this is going to equal 20 plus 4 times 7.7255. And let's see what our calculator says for that. So we clear it. So we go 4 times 7.7255, and then we hit enter, and then we add 20 to that, and we get 50.9 square units. Base times height plus 1/2 base times height, and we get 50.9 units. Square units. Okay, so that's a very quick recap on problem number 1. It would have been a whole lot more funner to find that area if we'd have found the length of CB and then use one of our 1/2 A, B, sine C rules, perhaps. But anyway, this worked just as well. Okay, that's problem number 1, and that's not the only way to do this problem. I'll bet you can all think of at least one other way to do all of these if you wanted to. All right, Mays out.